everyone, it's Miss V. Hope you're having a wonderful day and that you're ready for another day of science class. Now, before we start today's little note, I would like to go over a few important things that I emailed you yesterday. Now, these are a few important dates that I want to make you aware of, so take out your calendar and get ready to, circle some days. Very first one being June 12th. June 12th is going to be our very last day for introducing new material for the course. After this, you are going to have about a week to get some of your missing assignments in, and the very last day that you can hand in coursework is June 19th. So please, 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 if you have any missing assignments, try to start working on them now so that you don't have a big pileup of them in a few weeks. Because you do only have about a month before this due date. Now, please understand that I am here to help you in any way that I can. I'm only a short email away, and I'm more than willing to help you out. So please make sure to get into contact me if you need a hand. The other thing that I'd like to talk to you about is the physics booklet. So I've made a big booklet that contains the entire physics unit. And I did this because it can be really difficult to write down calculations and show your work for equations when you're trying to type it in on a computer. So by having these paper copies, you can do everything with pencil. Simply just take a picture of your work and email it to me or attach it to the Google assignment and hand it in that way. It'll make it a lot easier for you rather than having to fight with typing up your calculations, and it really helps me to see your work as well. So I really encourage you to do this. You can pick up a booklet at the school by arranging an appointment or by getting it delivered to your home. The school is more than willing to do that. And if you also are fine with doing things online, I will still be posting everything daily, as well as answer keys and videos here. So if you get the booklet, make sure you're still checking Google Classroom, and I will be still helping you out as much as I can along the way. Now, this booklet is pretty big. It contains the entire physics unit. Unfortunately, due to timing, we might not finish the entire unit, so you will only be assessed on the assignments that we cover in class. So if you would like to work ahead, go ahead, that is awesome. Those extra assignments you finish might just become a little bit of an extra bonus. They will definitely help you if you are going to continue on in grade 11 physics next year, so that's why I have included them in the booklet. However, if we do not cover them together in Google Classroom in these videos, I will not be expecting you to learn it on your own. So keep that in mind. Do not freak out if you pick up the booklet and think it's ginormous. We will be doing these things together, just like we have for the past month. All right, so now that that spiel is over, let's get into our note today about acceleration. And you probably already have an idea about what acceleration is, and let's think about it in a little bit of a different way. Now, what do you feel when you're moving really fast but not accelerating? I want you to think about, closing your eyes, if you've ever flown in a plane, or if you've ever, ridden in a car. Now, between that time when your airplane or your car speeds up and when it slows down, what do you feel? If you're not looking outside the window, can you tell that you're moving really fast? Now, I can't. So in that sweet spot where you're, moving at a steady rate, you're not really noticing that you're traveling at a fast pace. You only notice that you are moving when you are accelerating, when you're speeding up or slowing down. Now, this kind of ties in to our definition of accelerations. Now, physicists define acceleration as any change in velocity of an object during a time interval. Now here we have our little letters that we're going to be using. So A means acceleration, V, well, delta V, delta is a triangle, means change in velocity, and delta T means change in time. So as I'm, speeding in a car or slamming on my brakes or trying to take off for a race, essentially what I am doing is I'm changing my speed, and that is what acceleration is. So acceleration is not only by increasing your velocity, but it's also when you decrease your velocity, when you start slowing down. It can also be when you start changing direction, especially if you're swerving. Now, one thing that we're going to be doing a little bit of is graphing acceleration. So we are a little familiar with graphing because we've done it already with speed. And by analyzing graphs of distance versus time, you can already tell what the velocity is. You can tell if it's zero, constant, or changing just by looking at the shape of the graph. Now, you may remember that a velocity of zero, right, if you're traveling at a speed of zero, means you're standing still, and it's going to look like a flat horizontal line on your graph. Okay, the distance is staying the same as time is passing by. If it's constant, that means that it's going to be a sloped straight line. And if your speed is changing, it's going to be in a curve. Now, what we're going to be doing today is learning even more from a velocity versus time graph. So this would mean that instead of having distance on my y-axis, I'm going to have speed or velocity. All right, so in these two graphs here, they look very different. However, they are actually telling us the exact same story. This is a distance versus time graph, and it has a straight sloped line. Now remember from our previous conversation that in a position means distance versus time graph, when I have that straight slope line, it means that my velocity is constant. I am traveling at a constant speed. Now over here in graph B, I have now graphed velocity versus time, which is a little different instead of distance, right? Instead of graphing how far away I am from my starting point, I am graphing how fast I was going. Now this is a flat, straight line, and this shows us that the acceleration is constant, right? There's no slope here, and so that means that my velocity is zero. Or sorry, not my velocity. My acceleration is zero. I am moving at the same velocity. So maybe say this is 5 meters per second. I am traveling at 5 meters per second the entire time. I never change my speed. And that's exactly what acceleration is. So my acceleration here in both graphs is zero. Now for positive acceleration, over here in graph A, my distance versus time graph, whenever I have a changing velocity, it's going to be a curved line. Now, that same data for a changing velocity is going to look very different in a velocity versus time graph. Instead, it shows me that the velocity is increasing at a constant rate, which indicates constant acceleration. In this case, I was increasing my speed by, let's say, 1 meter per second every single second. So this would be like me, putting my foot down on the accelerator in my car, and now my speed is increasing with every second that goes by. And these are telling me the exact same thing. So I just have to remember to look at my y-axis to remember what I'm graphing, so I know what it's telling me. All right. Now I want to go through something also that tends to trip up some students. Now, the slope of the line in graph B is rising up and to the right. This indicates a positive slope, also known as rise over run is going to give me a positive number. Now, this means that the object is undergoing positive acceleration. The way I like to remember this is that if the line is going up, that means that it is positive, right? Think of like a thumbs up. It's a positive sign. Now, if that line is going down in a straight line, right? Down means boo, negativity, thumbs down. This means that my velocity is decreasing. So I am now slowing down. Right? I'm still changing my speed. I'm just changing it in the negative direction. I'm slowing down. And this on a distance versus time graph is going to look like a curved line, and it's going to start curving downward, right? In this case, you can almost see where now it started as a steeper line, and it's slowly getting more and more shallow. It's becoming more and more closer to the object stopping and becoming a horizontal line. All right. Now, one thing that you may have heard is the term deceleration, and this is referring to slowing down. Now, deceleration is not the correct scientific term. So in class, we're going to be using the term negative acceleration instead. Now, when you're calculating acceleration, which is what you're going to be doing a lot more of, I'm not really going to get you to graph too much of acceleration. It's important to remember that the definition of acceleration is the change of velocity of an object during a time interval. Now, change in velocity and time for this calculation is going to be denoted by this triangle here. Basically, delta, which is a triangle, indicates change in. So by having it in front of my v, I know it's the change in speed or the change in time. Now, the formula for acceleration is this right here, technically. So acceleration is equal to the change in speed divided by the change in time. If you ever forget this, it is going to be on your formula sheet that you have in this attachment. Make sure you keep this on you for the rest of the unit. And if you ever get stuck, you can always remember these triangles here. So if I'm looking for acceleration, I simply put my thumb or a circle over what I'm trying to look for, and my formula will appear. So I know what acceleration is equal to my change in speed over time, or change in time, sorry. And the way that I know that is because I have this little division sign in the middle. So this divided by this. Now, in order to calculate change in speed or change in time, sometimes my word problem isn't going to just give me one number. It might tell me that I started at 100 kilometers per hour and ended at 40 kilometers per hour. Now, that doesn't tell me my overall change in speed. Instead, I'm going to have to do a little bit of math. If this ever happens, right, many of you can do that math in your head. You say, oh, well, 100 minus 60 is 40. Now, you can also put in this formula here so that you don't forget to do this important step. So this would be my final speed, VF, minus my initial speed, or my starting speed. And same thing down here. My change in time is just my final time minus my initial time, or my starting time. Now, I can also use this fancy triangle to calculate some other formulas. So if I'm ever looking for time, I simply cover over the t, and I now know that t is equal to delta v, or change in time, divided by acceleration. Looks just like this. The last one is that if I'm looking for my change in speed, I can cover that up, and I now know that my change in speed is equal to acceleration times time. So when they're beside each other at the bottom of the triangle, you multiply instead of dividing. Awesome. So to calculate acceleration, you need 3 pieces of information. You're going to need your beginning velocity, which we're calling initial velocity, your end velocity, which we call the final velocity, and the time interval during which the change in velocity happened. So here's a sample problem that we're going to do together. You may have to write this in on your note. A biologist observed a cheetah reach a velocity of 19 meters per second from a standing start in a period of 2.0 seconds. What was the cheetah's acceleration? Assume that the cheetah runs in a positive direction. So if we know that the cheetah is moving in a positive direction, we know that it's going to be speeding up. Now, we also know that it started at a standing start. So we know that it started at a speed of 0, right? Because you're not moving when you're standing. And it ended at 19 meters per second. And it took our cheetah 2 seconds to do this. All right. So I know that my initial speed equals 0.0 meters per second. Final speed is a positive 19 meters per second. And my total change in time, which is already calculated for me, is 2.0 seconds. So what I can do now is substitute what I know into the formula. So my acceleration formula looks like this, right? Change in time, change in speed, which I have 2 numbers for. So I break it down to my final speed minus my initial speed over my change in time. Okay, so this is 19 minus 0 divided by 2. Now, of course, 19 minus 0 equals 19 divided by 2. And I now know that the cheetah's acceleration is 9.5 meters per second squared in a positive direction. Now, in order to get full marks on these types of questions, it is important that you always remember to give me the starting equation. So you get a mark just for using the right equation. Show me your work. So especially fill in those numbers. I know you might think it's silly, 19 minus 0, but make sure you're showing your work so that even if you make a silly mistake, I can still give you marks because I can see what had happened. Okay? And always also remember you get a mark for having the correct answer, obviously, but also for having these units. Now, acceleration will always be either in meters per second squared or kilometers per hour per second. We'll get into that in a minute. Don't worry too much. We're going to go through some examples, but those are the 2 units that you'll need to know. Oh, and look at that, units for acceleration. So in most cases, the units for acceleration are going to be meters per second squared. When we have speeds in kilometers per hour, you will just measure it as kilometers per hour per second, typically. And in these cases, I usually will very, very clearly outline what the unit is. So you won't have to worry about that too much. Just always remember to put that squared sign here when you're using meters per second. Now this is because we are dividing velocity, meters per second, by time, which is in seconds. So instead of saying meters per second times second, we just simply multiply those 2 together and we write it as meters per second squared. All right, so we're going to go through a few more practice problems just so you can get comfortable with this. If you would like to try these on your own right now, feel free to pause this video and then come back to it when you think you're ready and you want to see the answers. All right, so in a record-setting race, a race car reached a velocity of 145.08 meters per second in 4.48 seconds from a dead stop. What is the race car's acceleration? So from this, we know a few things. We always want to write down our givens first. So we know our final speed that our stock car reached was 145.08 meters per second. We also know that our initial speed is 0 meters per second because our stop car starts at a stopped position. We also know that it takes the car 4.48 seconds to reach this speed. So we go ahead and we are looking for acceleration. So I would look that up in my triangle and put in my equation. I know that acceleration equals my change in time change in speed over change in time. And I don't know what my change in speed actually is. So I can write out it's going to be my final speed minus my initial speed. Now I can go ahead and plug in my numbers and divide, and I am now given the answer. So my stock car, or my race car, accelerated at a rate of 32.38 meters per second squared. That's pretty fast. Awesome. All right, so here's our next question. And in this question, what I wanted to show you is what to do if you are given kilometers per hour instead of meters per second. We don't have to convert it to meters per second. We can still use this and just adjust our unit at the end. So Miss B is driving to 7-Eleven at a speed of 30 kilometers per hour. She notices someone walking down the street with a Slurpee and decides she needs a Slurpee now. She changes speed to 95 kilometers per hour in just 3 seconds. Calculate Miss B's acceleration in kilometers per hour per second. So I would usually give you this so that you can be reminded of what unit you're going to be writing down. Now, no, I would not actually speed up this fast. However, I do really like Slurpees. So these are our givens. We know that my final speed was 95 kilometers per hour, and my starting speed was 30 kilometers per hour, and my change in time that took me to reach that speed was 3 seconds. So because I am looking for acceleration, we are going to put in that same formula. Acceleration equals change in time, change in speed divided by change in time. I also still have 2 values here. I don't have an overall change in speed. So I'm going to show my work. And I know that it's my final speed minus my initial speed. I'm going to go ahead and calculate these numbers. And now I will get my average acceleration. So in order to get that Slurpee, I actually accelerated my car 21.7 kilometers per hour every single second during those 3 seconds. All right, so for our third equation, Sally is riding her skateboard at a velocity of 45 meters per second towards Main Street. She suddenly sees a for sale sign for some really cool calculators. While looking at the sign for 1.2 seconds, Sally slows down her speed to 30 meters per second. What was Sally's acceleration? Now, this is a good example of a question that is actually showing negative acceleration. Sally is slowing down here. Now, her final speed is going to be smaller than her initial speed that she started out at. So 30 meters per second is our final speed, and 45 meters per second is her initial. And we also know that it took a time of 1.2 seconds to do this. So once again, we are looking for acceleration. We're going to use that exact same equation. So acceleration is equal to the change in speed over change in time, and extend that equation here. I'm going to plug in my numbers, and what you will notice is because I am going to be subtracting 45 from 30, I actually get a negative number. Now this is really important because by negative 15 divided by 1.2 equals negative 12.5 meters per second. Now, by it being negative, I now know that I'm experiencing negative acceleration, or in other words, I'm slowing down. So it's always important while you're doing this to also make sure that you know if your number should be negative or positive, and watch out for that. All right, fourth question. Miss V is driving to school at a speed of 100 kilometers per hour. She suddenly encounters a great big mountain of Jell-O on the road. It takes her 5 seconds to pass through the Jell-O, and the Jell-O slows her car at a rate of 8 kilometers per hour per second. Now, how fast is she traveling as she leaves the Jell-O mountain? Now, of course, this would be just my luck. I probably just washed my car, if this ever did happen, but let's hope that this never does. Now, this question is a really good example of not asking for acceleration, but instead I'm actually asking for final speed, right? How fast was she traveling when she left the Jell-O mountain, her final speed, right? So this here gave me my time. It gave me my initial speed of 2 kilometers per hour, or 100 kilometers per hour, sorry, I don't drive that slow. And also my acceleration, which is 8.0 kilometers per hour per second. Now we always have to remember that I am slowing down in this case. So my acceleration is actually negative. And that's going to be big and important. Now, I will show you how to calculate this, but let's just think about this in our heads. Imagine a speedometer on a car. Now we know that I start out at a speed of 100, and it takes me 5 seconds, and in that time I'm slowing down. So say my little speedometer was here at the 100 mark. Let's break this into 5 equal sections. So I have 1 second passing by here, the 2 second mark, 3, 4, and 5. Now what I want to know is, what is this speed down here? This isn't an actual representation of an accurate speedometer, so just work with me here for a minute, but it does help give you an idea of the changing speed and acceleration. Okay, so after those 5 seconds, what is going to be happening? And we know that during each and every single second here, I was losing 8 kilometers per hour. So after 8, right, I can simply do 100 minus 8. So I know I was traveling at 92 kilometers here, and minus 8 again, and again, and again, and again. Or I can simply say, what is negative 8 times 5? By doing that math, I know it's negative 40. So between my start and my ending time, right here, I know that I changed my speed by 40 kilometers per hour. There's my delta V. Now the question is, what was my ending speed, right? What did I end up at? So I know I started at 100, I decreased by 40. Well, I can say, what is 100 kilometers per hour minus 40? Right? 100 kilometers minus 40 kilometers per hour is going to be 60 kilometers per hour. So that's my ending speed. So you can think through this process. However, I'm also going to show you how to calculate it. So I would write down all of my givens here and what I'm looking for, which is my final speed. And the very first thing that I have to calculate is my change in speed, right? We always start out with this triangle. I know my acceleration, I know my time, so the only thing that I can really look for is my change in speed. So let's go ahead and do that. We're going to cover that up, and I know that delta V is equal to A acceleration times my change in time. There we go. Now I'm going to fill in those spots with my actual measurements right there, always making sure I remember that my acceleration is negative, so I have to include that negative sign. Oh, and look at that, familiar number. So my delta V, my change in time, is negative 40 kilometers per hour. Now that I know that, I can find my final time. Now, you may remember from calculating acceleration that change in speed, is equal to my final speed minus my initial speed. And what we're going to do here is just rearrange this to try and get my final speed on its own on this side of the equation. So the very first thing I have to do is get rid of initial speed. So here I'm subtracting it. So in order to get it to the other side, I have to add it to both sides. Right? Do the opposite. So here I have added a positive, like adding my initial speed to both sides. Those two are going to cancel out. And that means that my final speed is equal to the change in speed plus my initial speed. Also written right here nicely for you. So now I can go ahead and take that and write it down here and plug in my numbers. My final speed is equal to negative 40 kilometers per hour plus 100 kilometers per hour. Remember that negative, otherwise we're going to get the wrong number, right? So my final speed is 60 kilometers per hour. Awesome. All right, everybody. Thank you so much for following along with this video. I hope that that makes sense. If you do need a little bit of extra help, tomorrow there will be some practice questions for you to work on so that you can get a hang of this. Hope you're having a great day, everyone, and see you tomorrow.